Good morning. I'm Michael Geithner, and today I'll be talking about the environmental impact of natural gas leaks. As you likely know, combustion of fossil fuels leads to the creation of greenhouse gases, which absorb infrared radiation and trap heat in the Earth's atmosphere. Combustion of natural gas, however, has been shown to be much cleaner than that of both coal and oil. When you compare newly constructed natural gas power plants to newly constructed coal power plants, you see up to a 60% reduction in carbon dioxide emissions. And comparing natural gas vehicles to gasoline-powered vehicles shows up to a 20% decrease in tailpipe greenhouse gas emissions. These reduced emissions have served as the major basis for the argument to increase natural gas use in recent years. Unfortunately, they fail to take into account natural gas leaks, which can greatly worsen its environmental impact. Drilling for and transporting a gas often leads to undesired losses. And in the short term, methane, which is the major component in natural gas streams, is much worse for the environment than carbon dioxide. Its radiative forcing, its ability to trap heat, is up to 37 times stronger. And although methane will be naturally oxidized to form carbon dioxide, this process takes a period of 12 years. So while in the long term you may see the same effects from the two gases, in the short term, especially with the increase in use of natural gas in recent years, you're going to see much more warming due to natural gas leaks. The good news is that the technology to detect natural gas leaks already exists and is widely implemented in the field. You have two categories, non-optical methods and optical methods. Non-optical methods start with basic manual inspection, but involve more technological methods like acoustic monitoring, where you look at changes in the background noise level along natural gas pipelines. This is very effective, but unfortunately can't detect small leaks. You can also use gas sampling, which uses flame ionization to detect natural gas leaks. This method is much more precise than acoustic monitoring, but is limited to the local areas where you actually perform testing. There's soil monitoring, for underground pipelines, where you inject tracers into your natural gas and monitor the soil for the presence of these tracers, which would only be detectable if natural gas was leaking out of your pipeline. The drawback here is that it can get expensive because you're continuously injecting tracers into your natural gas stream. You also have flow monitoring, which is one of the most straightforward methods to implement. Here you look at either mass flow or pressure changes over sections of pipeline. It's very effective, but it can cause false alarms because these changes can be due to other factors. And it also doesn't give you the exact location of leak, only the section where it may be occurring. And finally, you can use software-based dynamic modeling, which gives you a live model updated with real-time parameters from your system. It can predict where leaks may be occurring, but it can get expensive for large pipe networks. The other option is an optical method, which uses the absorption or scattering of radiation by natural gas when it's released above the pipeline. You have active monitoring, where you use either a laser or a broadband source to provide something for the natural gas to absorb or scatter. And typically here you want to use multiple wavelengths to avoid false alarms. And you also have passive monitoring, which involves either thermal imaging or multi-wavelength imaging. Here you eliminate the need for an energy source, but you do often need to use more expensive detectors because you're taking advantage of naturally occurring radiation. So if all this technology exists, why isn't there more monitoring at present? The simple reason is that there's no incentive for companies because it's just added cost for them. So to get this to happen, we're going to need increased government regulation. Unfortunately, this often takes time, and we're talking about short-term effects that we really want to reduce. So in the meantime, the government's going to have to work with companies that are environmentally conscious and willing to do this on a volunteer basis. This has already been happening in some states, especially major natural gas producers, and so we're taking steps in the right direction, and in the future, hopefully we'll either incentivize leak reduction or penalize natural gas leaks. So in summary, sufficient and affordable monitoring technology already exists, and its increased use would actually lead to the development of lower cost alternatives and improved technology. But the major barrier is just a lack of incentive for companies to spend the extra money for increased monitoring. So we're going to need increased regulation or incentivization in order to convince them to do this. And hopefully addressing the short-term problems caused by methane in the atmosphere will ultimately make natural gas a much cleaner alternative to coal and oil. Thank you for your time, and these are my references if you'd like any further reading on these topics.